All right. Well, welcome back. This is the first day of section 8.3.4, and we're going to be looking specifically at how many triangles can I make. So the ability to make a unique triangle requires a certain number of pieces of input so that if I give you those pieces of input, we will all make the exact same triangle. Today, we're going to start learning kind of how to determine how many pieces you need so that we all make the same triangle. Problem 891. How many different parts does a triangle have that can be specified or measured? What are these parts? So let's give you a moment to think about that answer. If you said that there are 6 parts, you are correct. So let's see here. There are 6 measurable parts. That would include 3 angles. So there's an angle here, there's an angle here, and there's an angle here. Those little tick marks are showing that these angles are different size angles. If I use the same number of tick marks, those would be equal angles. So these are 3 different angles. And then I could say there is one side, there's a second different side, and a third different side. So of the 6 parts, well, hopefully someone will get that phone. All right. So of the 6 parts, there are 3 angles that are measured in degrees, and there are 3 sides that are measured in units, like, inches, centimeters, feet, whatever. So those are the 6 parts. Today, triangles are important shapes. They are basic building blocks for many architectural designs and structural supports. A tripod stool will tend to be more stable than a chair with 4 legs. This is because of the triangles. In lesson 8.3.3, really? A tripod stool tends to be more stable than a chair with 4 legs. That sounds odd to me. Maybe. In lesson 8.3.3, you became familiar with the technology tool used to build for building shapes. I'm going to move this up here. For building shapes and gain some basic information about angles and triangles and quadrilaterals. Today, you will do more in-depth investigation of triangles. You will learn about when a triangle can and cannot be made, and you will discover the necessary conditions to create a unique triangle. So triangles are important. They said they're important. They're so important they actually have their own math class. It's called trigonometry. So, and you'll study that stuff in high school. Go ahead and get your homework out, and I want you to check your answers to your homework. You can start and stop your video part, start it, pause it, so you can check the answers. Um, this was problem 885. Part A was 50, B was the 170-degree angle, C was the 190-degree angle that finishes the total 360. D, a 270-degree angle counterclockwise would go this direction. So if this is 90, the backside of this is 270. Here's problem 86. Here's problem 87. If the radius is 3, the diameter is 6. If the radius is 1.5, the diameter would be 3. And in this picture, if the radius is 1 millimeter, the diameter is 2 millimeters. Problem 88 uses, I used in this method the 15% of 538. Of means times, 15% as a decimal, and I got that. If that's the commission, then the total would be $7 times 18 plus the commission. And therefore it'd be a total of $260.70. Problem 889, I used a proportion, but instead of cross multiplying, I divided both of these by a factor of 2. It's kind of like the giant 1 method, right? Problem 890, since these two angles add up to 90, I made an equation, subtracted 37 and got 53. Problem B, these two angles made a straight line. So if this is 85, this is 95, because together they are 180. Problem C, these are vertical angles. They're equal to each other. And D, these two angles add up to 180 again, so D has to be 43. Wow, keeps on going. Angle E, these add up to 90, so E is 75. Angle F is 153 because these are vertical angles and they're equal. And if these two make a straight line, then these would add up to 180. So that makes angle I 27 degrees. Problem G, this is going to be 180 degrees. So G would be 65 degrees. And problem H, you end up with another 180 degree linear pair. These two make a straight line again. So go ahead and check your homework, make corrections as you need, and then we will move on. So we're going to be using a tool today. It's also linked on your Google Classroom assignment, and it's linked in other places. But this GeoGebra tool, there's one that's in our textbook that's good. I think this one's better. So I'm going to show you how to use the GeoGebra tool for completing today's problems. They ask you to create a triangle with a 90-degree angle and a side of 3.7. So to use this tool, I want to create a 90-degree angle and a side of, what was it, 2.7? 3.7. So this takes a little bit of manipulating here, but we want to get a 90-degree angle. So you might have to play around. Oh, I got it right there. Look at that. You want to move that angle around, so you want to swing those points around, and you can see it changes the angles. But then they want to get a side of 3.7. Well, which side should we make 3.7? So if this lets me move the angles over here, I can use this to increase the sizes. So maybe I'll make the green one 3.7. If that's the case, then this one, I'm going to have to aim it correctly. And I'm going to try and get it as close as possible. And then I'm going to take this and I'm going to swing it right into its spot. And maybe this is going to be my triangle that I make right here. So that's one possibility. I could also have, instead of making this 3.7, I could have made this one 3.7, which would have meant that this is going to have to, if I want to complete this circle here, or this triangle, sorry, I might have to bring this down a little bit so that I can complete this, maybe as so. So here's a different triangle with a 90-degree angle and a side of 3.7. What if I made this side 3.7 also? Let's see, there's a 3.7. That's not going to work, but if I make that a little smaller, now I've got two sides that are 3.7. So, I don't have my 90-degree angle anymore. Oh, darn. So I'm going to have to do something about that. So to get my 90 degrees back, and as you're experimenting with this, just get close. It's not perfect, but so I guess we can't do two 3.7s because that would lose our 90-degree angle, wouldn't it? All right, so there's the best I can do for that one. But this, again, is a different triangle. So As we go back here, an angle and a side made more than one triangle that are possible with this angle and that side. In fact, I could probably come up with at least 3 different triangles, maybe more. Problem 892. How many different triangles do you think you can make specifying only 2 measures to use the triangle's parts, such as 1 angle and 1 side, or 2 angles or 2 sides? Use the tool located in your Google Classroom that was demonstrated by your teacher. Investigate this question. Each person you will attempt to build a triangle with the specified angle measures and or side lengths listed below without looking at their partner's drawing. For each triangle that you build and each set of conditions given, do the following. Compare the triangle that you built with your partner and that one that your partner built and decide whether they are the same or not. Are these triangles the same or different? Are there any possible triangles that can be built using the same conditions? Any other ones? State your conclusion. And then the second part to this, sketch the triangles on your paper, labeling the given angles and side lengths. So what I would do is if you can find a piece of patty paper or tracing paper, you could carefully, don't press too hard on the screen, but you could carefully trace the triangle you create and then transfer that to your notebook. What I want you to do is I want you to try to use the GeoGebra tool ahead of me. I want you to make a triangle first with the conditions, and then I'm going to make one and you and I will compare ours, meaning you'll check to see if you got the same triangle as I got. So here we go. 892A, using that tool, I want you to build a triangle with 1 side length, 4.5 centimeters, and 1 angle of 135 degrees. Go ahead, pause your video and go make your triangle. A side length of 4.5 centimeters and 1 angle of 135. Angle of 135. What was that again? And a side length of 4.5. So I think I'll make this 4.5. And I'll make this 135. Okay, wait, going back down to what they asked for. I forget quickly, 4.5, okay. And then this one, I'm gonna go ahead, I'm gonna make it meet this triangle. Darn it. Okay, close enough. So here's my triangle. Hopefully you had maybe did something different. Did you put your 4.5 side here and the 135? Did you put your 4.5 on the green one? Or did you put your 135-degree angle at BAC, meaning at angle A? So you may have a different triangle than me. So having an angle and a side given is not enough for us to get unique triangles. Okay, the next one. They want you to make a triangle that has 2 angles of 90 degrees and 60 degrees. Pause your video, go do that, and then restart your video and see if you got the same one as me. And a 60. Let's see here. And a 60. I'm having trouble getting the 60. There it is. Okay. And I think I'll make this like, oh, how about if we make this one 5? Now we'll make this one 6. We'll make this one 3. And this one will be whatever it needs to be. Okay, so there's my triangle. You might have had a 90 on this side and a 60 up here. Maybe you had a 90 and a 60. That would make this a 30. Or maybe you had the different sizes. Having two angles does not necessarily give us the same triangle. In fact, watch this. If I were to make this into a 4, and I were to make this into a 2, and I were to bring this down, I could say right now that this is a different triangle just based off the side lengths. The angles only determine how wide open these sides are, but you could use varying lengths and still make them connect. Like you could make this say 5 and this one 2.5, and then you could bring this one up a little higher right there, and you still have a different triangle. So having two angles, not enough to tell me that they are the same triangle. They are definitely similar, same shape, but not the same triangle. They are proportionally grown. All right, next one. Let's see here. Part C, 2 side lengths, 4.5 and 7. Okay, go ahead and pause your video and then try your own. So let's see here. Okay, here's my 4.5 and 7 triangle. I kept the 90-degree angle there. Doesn't have to be. I mean, I'm sure I could bring this one here and then do that, and that would make a completely different triangle, obviously. But it would still have a 4.5 and 7. So I just demonstrated 2 different triangles. So I'm assuming your triangle might look slightly different from mine also. So having a side and a side made different triangles. So on part A, a side and an angle, that made different triangles. An angle and an angle made different triangles. A side and a side, we made different triangles. Part 93. Discuss with your team whether or not knowing only 2 of the 6 requirements for parts of a triangle is enough to always draw exactly the same triangle. Test your conjecture with more examples until your team is satisfied that you are accurate. Write a summary of your conclusions and your reasons for them. So I would say, and I'm going to type this one, that if I had to put a statement to all of this today, that knowing only 2 of the 6 possible measurements of a triangle is not enough to create unique, ooh, there's a good word, unique triangles with only 2 measurements. We can make different triangles but not necessarily the same triangle. So that's my statement. I think that's a good statement for right now. As we get further into this, so day 2 of this, we're going to be looking at whether or not 3 sides or 3 angles or 3 parts is enough to make unique triangles. So there we go. Your homework, I want you to go do 898 to 8103. Take photos of that homework and attach it to your Google Classroom assignment. And that is it for right now. Thank you for listening. Have a good day.